In a three-tier architecture, you can scale the presentation tier by adding web servers and the business logic tier by adding application servers. But what do you do when the database itself becomes the bottleneck? In this video, we look at the two fundamental mechanisms for scaling the data tier, replication and sharding. In most applications, the data tier absorbs the heaviest and most unforgiving load. Every page load, every search, every transaction hits the database. As traffic grows, a single database node starts to buckle. Reads contend with writes, query times climb, and the hardware ceiling approaches faster than you expect. You also have no fallback if that one node fails. This is the pressure that replication and sharding are designed to relieve. Think about a busy library. If there is only one copy of a bestseller, readers must queue. Printing more copies solves the waiting problem, that is replication. But if the library itself overflows with books, no amount of extra copies helps. You need to divide the entire collection across multiple buildings, each responsible for its own section. That division is sharding. Both problems are real, and both solutions are often used together. Here is what the data tier looks like when both techniques are applied. The application tier sends all writes to a single primary node. That primary continuously copies or replicates every change to one or more read replicas, which the application can query freely. Separately, the data itself can be partitioned or sharded across multiple nodes, each owning a distinct slice of the data set. Replication multiplies read capacity, sharding spreads the data volume and write load. Trace a write first. The application sends it to the primary, which commits and then streams that change to every replica. There is a small window, called replication lag, where a replica has not yet applied the latest write, so a read sent immediately after a write might return slightly stale data. This is a key consistency trade-off. Reads, meanwhile, can be distributed freely across replicas, removing that load entirely from the primary and letting the system handle far more concurrent queries. Replication and sharding each solve a different dimension of the scaling problem, and each introduces its own costs. Replication is relatively straightforward to add and immediately relieves read pressure, but the primary remains a write bottleneck and replicas can lag. Sharding unlocks true horizontal growth for writes and storage, but it forces your application to be shard-aware, and queries that span multiple shards become expensive operations that must be carefully designed or avoided. The practical advice here is to sequence these decisions. Most systems should start simple. One primary node, add read replicas when query load climbs. Sharding is a significantly larger architectural commitment. It touches how your application constructs queries and how you handle transactions. So defer it until you genuinely cannot fit data or write throughput on a single node. When you do shard, the single most important decision is your shard key. A poor choice creates hotspots where one shard absorbs nearly all traffic, defeating the purpose entirely. To summarize, replication and sharding are complementary tools for a data tier that has outgrown a single node. Replication copies the full dataset to multiple nodes, so reads scale out and a failed primary can be replaced. Sharding divides the dataset so that no single node bears the full weight of storage or writes. Both add real operational and consistency complexity, so treat them as deliberate architectural decisions, not defaults to reach for on day one.